Hello, everybody. Welcome to another iCow webinar. Thank you all for joining us. And we're going to have a fantastic journey today. So many of you know that I'm mad about cows and that I've raised various breeds in my life and my journey in agriculture, including Jerseys, Friesians, and finally Ankole. My choice to raise Ankole was because they're so beautiful and they're low maintenance. They are by far the easiest and most intelligent cows I've ever reared. They're also the most economical and productive, eating little and giving birth to healthy, trouble-free, beautiful, bouncing little calves every year. My two in-calf heifers soon became a small herd. I studied their breed and I learned about their incredible traits and resilience to conditions in Africa. And in the process, I learned that Africa is home to an incredible over 100 cattle breeds. Did you know that? And they're all super stunning, yet hardly recognized. And that we're losing these at an alarming rate in favor of imported exotic breeds. And I personally feel so compelled to actually want to see them all. In January, I heard about a training session on ultra-high density strip grazing in Zambia, being given by Africa's famous livestock breeder, Johan Zietsman. I had an inkling this was really important, not only in regenerating landscapes and producing cattle sustainably and profitably, but also as a means to preserve our African livestock genetics. I jumped at the chance, and I soon found myself being lovingly welcomed into Welkom farm, where in addition to a lot of learning, I found my sister from another mother, Sally Greyvensteyn. Sally and her husband, Robbie, described themselves as Johan's students and were hosting Johan and his wife, Brenda, for his course, delivered to interested regenerative cattle breeders in Southern Africa. The next few days were best described as being a crash course in ultra-high density strip grazing from morning to bedtime. In the mix of all the learning that you'll hear about today, through Johan's skilled and trained eyes, we were taught how to select the right breeding genetics through careful observation of bulls, young and old, selecting for traits in resilience for Africa's ticks, as well as performance traits in their musculature. And believe it or not, their characters count. So I'm so grateful to Sally and Johan, and I cherish this opportunity of sharing some of what I learned with them, with all of you today. So, to set the scene, Sally joins us in a short video with her fabulous cattle, describing her experiences with ultra-high density strip grazing. Hi, Sally.
Hello, Sue.
So, Sally, do you want to tell us a little bit about your farm here and the cattle and the grazing that's happening here, where you started and where you are now, and what your thoughts are on the same?
Yeah, Sue, we started quite a long time ago and have learned for a while, but we see now that management is very easy because you can see if there's a sick animal, you can see if there's a sick calf, or that there's a problem with calving. Your grazing management is much better because it's not selective grazing, so they are forced to eat everything. This here is stargrass in the first part of the block, and then inside is a planted pasture grass, which is from Brazil, but it requires a lot of fertilizer, so we won't do it again. We'll rather just stick with the natural grasses and the bush. In the background is pigeon pea. We call it ngolioli here, and it's a legume and it benefits the soil, and we're going to plant more of that in hedges, and next time we'll plant it much more dense than that. But the cattle are enjoying the leaves. You can see up in the distance they're actually eating the leaves, and the condition of the cattle is very good. So we can check on body condition all the time. If the body condition drops, then we know that there's something wrong. we're not doing it well enough. The bulls are in here as well. So in this herd there's about 200 cows, and we've got only 100 that need the bull because we've got some calves already from what we call winter bulling. So this is the summer bulling, and so we've got 4 bulls in here as well. So here you can use 1 bull to 50 cows because they don't have to go far to see the cow on heat.
And what have you, when you started, you mentioned that there was a difference between the body condition of the animals when you first started and introduced them to the system and their body condition now. What was it like before and what changed?
So the body condition was lower when we started, and initially the body condition dropped when we started, but through time and perseverance the body condition has improved now. We do supplement with some sunflower cake in the winter because our winters are very harsh and we don't get rain in winter, and that has really helped. So you need the protein in winter, but yeah, the body condition is excellent now, and admittedly we are in summer now, so the body condition should be good, but we've seen all the pastures improve and the legumes are increasing all the time. So
natural legumes
all
or
natural legumes, yeah, natural indigenous legumes. So in here those shrubby small shrubs are just natural legumes that are increasing, and yeah, it definitely favors the cattle eat the legume more in winter. So at the moment it's flowering and it's going to seed, and then this pasture we won't graze it in winter, we will graze it next winter. So next summer it'll be left out to grow, and then we'll come back and graze in winter so that the roots can get deep next summer. So we alternate between winter grazing and summer grazing, and we do the same in the bush. And actually the cattle do better in the bush than they do in the planted pastures. And we've got friends who are doing dairy farming, and they're putting the cows in and the heifers into the bush, and they're doing far better than on the pastures because of the diversity.
The diversity of different feeds and grasses,
yeah,
and what's coming up.
They eat the leaves, they eat, they just do so well. They initially have to get used to it, and eventually they do so well in the bush because of the diversity of the grass and the leaves.
So these are the cows. This is the line, the plot that they're in. How big is it, Sally?
Probably about 80 by 50 for the night.
Meters?
Yeah.
How many animals are in here?
210.
210 animals, so it's ultra high density grazing. So they'll eat this place down throughout the night, and then in the morning they're going to move into a new patch.
There.
And this will be left to recover. And some of these here are where they have been in the past, where they have grazed down. And Sally, you said that in the beginning, because your pastures also adapted to the feeding that was happening on them,
yes.
And you said that in the beginning, when you started, your cattle didn't do as well as they're doing now. Do you want to tell us why?
I think they had to get used to the system, and they've now learned there's no stress for them. They know that when they open the wire they must go and eat, so they're eating extra than what they would eat before, and so they put on weight. We've been doing it, the pastures have improved.
Yeah.
We don't put any fertilizer on because they are fertilizing the grass with their dung, so we don't need to fertilize. So for at least 4 years we put no fertilizer, and we used to use urea We used to always be putting fertilizer, and now we never need to.
So you've saved a lot of money, and in fact you're using the cows to fertilize the grasses that are growing up behind them, because they're dumping a whole bunch of manure as they're grazing like this together, and they're non-selective, so they're clearing areas, dumping manure and urine, moving on.
Yeah, if they select, they eat the palatable species down hard, and then they leave the unpalatable species. So we've seen a decrease in the unpalatable species. If you allow them to select and graze what they choose, you end up the unpalatable species get left and they take over.
Yes, yes, yes. And have you seen that happening in some blocks?
Oh, definitely. We've seen. Well, now we don't leave it. So we push the cattle in like this, and we don't let the cattle select anymore.
Okay. Well, they certainly look really lovely.
Thank you.
Sally again. Quick question. So, training your animals to get used to a system like this, when is the best time to train them, and why?
So you can start in summer, because the earthing is better in summer, and in winter the earthing is poor. Also, then they're not distracted, they're just eating lots of lovely green food. You start with a bigger area with a few animals so that they learn, because otherwise they just mob and dash and break the wire. But you can expect the wire to break a bit. It's not too much of a problem. Push them back in and tie the wire again. So for each unit of cattle you need 5 cranks and 5 wires, and you have 2 long wires running the length of the field, and then you divide it into small blocks. So you move 5 times a day, so a bigger block at night, and in the day it's a lot of visibly working out if the animals have finished the grass. So you have to check a lot that they've eaten everything before you open it, and they have to get used to that because they've always been selective grazers. So then once they've eaten it, then you can open up. So you have your 2 long wires and then 3 short wires, so 1 ahead, so you make a block ahead of where they're grazing, and then the wire that's stopping them. Yeah, so you can get away with 4 wires, and yeah.
So you've got 2 long length wires,
yes,
and then you've got those that are transecting across, yes, that you're moving. So you've got 1 behind, 1 that you move in front.
You don't have to have 1 behind most of the time, because they're not going to go
Oh, they're not
back
going to go
on
back.
what they've finished.
Huh, clever.
So that's also an advantage, because you're not going back to where they've dunged, and that reduces your worm, your parasite load. And once they've fallowed, once they've dunged and manure and urinated on a block, they're not going to want to go back there.
So they're always wanting to move forward because they know and they're trained eventually that the feed is in front.
Ahead.
So you don't need a wire behind them, you just need to put 1 up in front.
Yeah.
And then when you open them into that one, you want to know that you've got another one that is blocking them from just going straight through the entire length.
Yes.
Got it. Wow.
And then you also want to check that their belly is full. You can't starve them, so always look on the left hand side at the triangle that's at the top of the body, behind the ribs, to make sure that there's not a hole. It's like an indentation that must be level and full, so that you make sure your animals are getting enough food every day. Don't starve them. You take them to water twice a day, and it's easy. You just go back along where they've come from and always start the wire at the water.
Okay, got it. Brilliant. Thank you. Thanks, Sally. Fencing that is moved every, 4 times a day do you do, Sally? 5 times a day? 4 or 5 times a day into blocks like this. And you don't come back to the same block until it's grown? but you really put in a high density of cattle. We're just going to go to where they came from before they moved into here, and you can see all the animals have got incredible room and fill for this evening already. See that density of animals. Sasha, hello. Hi. And this is where they have just come from, where they have eaten this down. This electric fence is still here. That's what they've eaten down. This is a new block, green block that they've been moved into. And there's Sally with the doggies at the end. Wow. I hope you all enjoyed that. I miss Welkom Farm. I miss those animals. So a couple of things there that are really interesting. Cattle eating all day and at night when they want to as well. So a lot more feed required, but a lot more yield produced. So I'm sure you all have a million thoughts and questions. Please share them in the chat and we'll come to them in the question and answer session at the end of our presentations. We'll get to them, but before we do, I want to introduce our guest speaker. Dr. Chip Stem is an American veterinary economist and graduate of the University of Nairobi, Faculty of Veterinary Medicine, and Tufts University, Fletcher School of Law and Diplomacy, with more than 30 years of large-scale project design, senior management, strategic planning and implementation, experience in Africa, the Middle East, South Asia, West Asia, and North America. He's a CEO of the Livestock Trading Systems Group, which besides the livestock activities, his livestock activities also includes Regen-360, the science-based regenerative ag and grazing company. Chip's also a student of the Elaine Ingham Soil Food Web and perhaps the most meticulous of her students that I know when it comes to data collection and documentation. He joins us to share his experiences of converting sand to meat. Yes, you heard me correctly. No pun intended. Chip, thank you for joining us today. The floor is all yours.
Thank you. So I'm the lucky one who gets to present the results of really a nice, closely knit team we have focusing on regen ag and grazing down at the Tana River Delta in Kenya, as well as the whole community who's come together over this beginning of what we think will be a fairly large scale and really exciting project. And we just want to present our results. I've been studying regen now for about 8 years. Some of us are slow learners, so I guess we need more time. And we decided to put what we've learned to practice, and we were going to develop much more arable land than we did, but because of El Nino, we knew that would be flooded. So we chose a 100-million-year-old sand dune because we're in an area that used to have an ocean overhead. A little background on why we got into regen ag and grazing. It was effectively for economical reasons. We desired to export livestock to the Middle East and Gulf countries. And much of our competition sits in Somalia and Sudan, which is anywhere from 8 hours to 3 days shipping time away, where we've got 7 to 12 days shipping. So we've got to become economic and low cost, but high quality. And regen seemed very attractive in that way. So this is what we began with. We cleared some bush. It was just sand. We actually dug down at 1.15 meters, and we still were digging through sand. So soil organic matter 1%, water infiltration really low, or really fast, as you can see, which means the dirt's not going to hold water. So we thought this would be a fun challenge to try, and had maybe what I like to call beginner's luck. to do this, the pathway for us was creating what we call biosoil, which is basically Elaine Ingham's biocomplete compost methods adopted locally, of course, and we quality assure everything in the laboratory. So we put up labels on our piles, as you can see here in the picture. And if we are addressing a certain crop in terms of ecological succession, we can scroll down there and right away pick up the right color-coded pile to be able to deliver the extract or the compost, what we call biosol. So this has worked out very well for us, and this is our production center. We're about to add a couple more over the next few months. Where we began and where we got to with some of our plants 75 days later, so 2.5 months later. We were creating good soil and I think reasonable rhizal sheaths and spheres. Now, of course, that's not everywhere. We did 40 trials, 8 by 9 meter blocks. So we were testing a lot of different species, a lot of different combinations, all under the same irrigation system, which are floppy sprinklers, solar powered. We call them solar floppies here. They give a nice even water distribution through the field, so are perfect for regenerating soil health. And this was just the most exciting thing for us, is the power of diversity. On the left here, you can see this maize field. Some of our maize fields had 3 or 4 other species in them, mimicking what's often done in Kenya, maize and beans and so forth, but low diversity. And we kept the irrigation low, about 200 to 250 millimeters over this 90-day period. But we put that irrigation evenly over everything. And on the right was over 30 species that we put in together. So the same system, the same everything, except the diversity was involved here. And you can see one is a failed crop and another is something really quite interesting, at least if you're if you're ahead of livestock. These are the grasses. In the forefront are indigenous and some Bracharia as well, that Sally mentioned, exported to Brazil and re-imported back. And in the background is that more diverse mix that we grew originally for silage, but it turns out I think will be really good for grazing as well as we move forward. This is our ultra high density grazing. It really mimics Gabe Brown's approach, where we try to graze 1/3 and trample the rest. And you can see it being trampled here. And that basically keeps the ground covered and feeds the soil and helps develop those luscious rhizospheres and rhizal sheaths. And I thought I'd just leave you with some happy goats grazing. And this is what their actions were when we released them into that background you saw a moment ago.
Fabulous.
Oh, I can watch this all night, but I'm sure she would lose her patience with me. Oh, I probably better stop here. But as I said, we've involved the local community. They're really on board with us now for our extension. And this is obviously the techniques and model will follow around the 20 trials now in our second, and just fine tuning things as we move forward and expand. Thanks.
Wow, brilliant. Thank you for that, Chip. That's actually really amazing. I love the term that you've used there, where you've said productive chaos.
Yeah, it does look like chaos to most people when they walk in, no doubt. But you know, this is the power of nature and diversity, right?
Isn't nature and diversity just that, productive, resilient chaos? So, so have you started measuring any of your livestock yields yet?
We have not. Unfortunately, we do have a scale now on site with 100-gram increments, so that'll help us develop trials. We focus this time, besides these little experimental grazings and hay making silage, on collecting seeds.
Okay.
We strongly believe in epigenetics, and we got some crops didn't do that great, but we took the best that we could. Now we're using them to replicate out again, and then we're at 3.5 acres now, then we'll go to 25 acres, and we'll scale up, building our own seed base as we go.
Wonderful. So basically what you're doing is you're creating, you're mimicking what would have happened if those seeds had just dropped there and grew there anyway, and you're going to allow the natural biomes that will make those seeds flourish actually work together, as opposed to just buying seed from the outside, growing it, working with the best that are there, that will be adapting there. The endophytes will be adapting, the soil biome will be adapting, everything will, and it'll just be, well, the chances will be higher and more successful, and the diversity as well, because you're mixing a lot of seeds I saw there.
Yes, exactly. And rather than letting nature do it, we are collecting the seeds and then remixing, trying to get the better combinations. Over time, when we regenerate rangeland, it'll be pretty much exactly like you said. And yes, for us, the diversity is just really the key, but also we obviously want to avoid fancy hybrids because they are, many times the mycorrhizal receptors will get bred out. So that can be a real problem if you want to do a good regen system and make progress quickly. And our other goal here is we'll be working with about 10,000 smallholder farmers in the area, and we need to bring them into this regen fold. And if we can do it there with local seeds and with the soil biology we grow with extracts and so forth, I think they'll be really winning as well.
Fantastic. So Chip, for those of us that are not very familiar with your reference to the mycorrhizal fungi, do you want to just elaborate there a little bit?
Yeah, some experiments, I'm sure others by now, but Adam Cobb of the Soil Food Web School have done using sorghum, is if you remove or if you plant very good hybrid sorghum, even in a regenerative system that still have plenty of those wonderful endophytic mycorrhizals in, those plants won't do well. And his view is they've lost the receptors. Over time, they readapt, they will gain them back.
Yeah.
And grasses in particular, 80% of the world's plants species they think are mycorrhizal, are AMF adapted, but grasses in particular are very strong with this. And of course, things like sorghum and the indigenous grasses and maize, or even bananas, are all grasses, and we're growing all of those.
Yeah, exactly. What was so amazing about your presentation there, I'm talking about mycorrhizal in the grasses and looking at the rhizos sheath that you had in, did you say that was 2.5 months?
Yes. I mean, yes, that was 75 days after planting.
Absolutely crazy. Would you mind just flicking us back to that picture again, sharing your screen again, and just taking us back to that specific picture? For those of us that might be wondering what we were looking at there, for those of us that are learning, that are learning about soils and learning about the rhizos sheath and the plant exudates that feed the microbes in the root area and in the root zone, you can measure your soil health and the productivity and actually even the nutrient capacity almost of your plants by looking at your rhizos sheath. If you've got a very big rhizosheath and lots of those very fine hair roots, it means that your plant is functioning with the biology in the ground, is managing to move around and look for nutrients, and the biology of feeding the nutrients, the minerals, back to the plants, and the roots are growing out and getting more and more, and you end up with that. It's a no-brainer that the lush green above the ground is basically there because of all of this stuff that happens below the ground. And normally when we're looking at what's above the ground, we don't tend to look what's below the ground. So it would be interesting to see, Chip, if you take an example of that maize field on the side and pull out a plant of those and have that picture of the two of them side by side.
Yes,
and
yes.
the crown is probably...
We actually have that in another presentation, and I knocked it out because of time, but you're exactly right, Sue. It's all about what's underground, and as farmers, we tend to focus on what we see above ground. And I think that's the biggest mistake. As people like Gabe Brown say, the most important tool in Regen Ag is a spade. Stick it in the ground and look at your soil, and looking at this actually was shaken off. So it's not the best picture for this, but what we're really interested in, you can see a few of these dreadlocks, this Rastafarian dreadlock look around the roots. That is when you have the biology nurtured by the plant and nurturing the plant and protecting it from disease. And one of the ways to measure this is we found when we would get a pest infestation, we would take some Brix measurement off of leaves, which is looking at the total dissolved sugars in the leaf. And every time we had a pest infestation or a disease, those plants that were infected had a lower Brix than their neighbor plants that were healthy.
I'm not sure if it's Chip or if it's me. It's me.
Then, can you hear me? Can you hear me? Can you
hear
me?
We can hear you.
Okay, great.
We can hear you. Yeah.
Okay, maybe Sue's having issues. The only other thing I want to say about that is when we would spray our extract on that we got from our biosoil or compost, within 2 hours, the Brix level of those infected plants would go up, and sometimes we would be able to cure the disease with 1 or 2 sprays like that of the biology. That extract is basically life plus some messengers, chemical messengers to encourage microbes and the plant telling them there's a healthy environment.
So much to unpack right there, Chip. That's a whole other webinar. Thank you so much. Thank you for sharing your presentation with us. We look forward to, it's really great that you're pioneering in this space, doing the small ruminants, ultra high density strip grazing is really, really cool. I look forward to future presentations from you where we can talk about what's that turned into in terms of meat yields and money. I'm going to ask,
Thanks, Sue.
Pleasure. In the introduction to his famous book, Man, Cattle and Veld, and yes, you must get a copy of Johan's book. In the introduction in his book, he speaks of his insatiable appetite for knowledge about breeding cattle whilst improving the land, something that was cultured in his childhood, growing up on a farm, running more than 10,000 cattle. Now a world-renowned speaker on the subject of ultra-high density strip grazing, it's my absolute honor to have Johan join us here today to share his immense knowledge and passion in this field.
Okay. Fundamental aspects of successful livestock production on veld, challenging conventional wisdom. So basically it's about a whole which composes cattle, grass, and obviously the manager. So that's what we're going to talk about. It is essential that we make a distinction between production per animal, which is the conventional model for cattle farming, cattle ranching, where production per animal is measured and selective grazing allowed, and cattle are selected for growth, which arises in lean cattle with high inputs, as opposed to production per hectare, which is the goal I suggest we all follow, which requires non-selective grazing to fully utilize the grazing, as well as to improve the land by high animal impact and time-controlled impact, and by breeding fat cattle with low inputs. And there's a relationship between what we're breeding cattle and with cropping as well, which I see a lot, and Chip alluded to that, is that we're producing low nutrient dense cattle, and we're producing low nutrient dense crops as well. And that is a problem. We have to go back to the old varieties and the older breeds that we have, particularly in Africa. In fact, for our environment, there are no better cattle anywhere in the world than what we have here in Africa. Well, you can just maximum. So our goal is maximum sustainable profit per hectare, which includes the sustainable part, includes economically sustainable and ecologically sustainable. So on the left-hand side, you can see maximum number of cattle. We need very high stock densities to increase our stocking rates and increase the number of cattle we can carry. And then we require early maturing fat cattle, which I was talking about, nutrient-dense cattle. We are in grazing management and also in breeding, we have to mimic nature. And that's an example of a large herd of wildebeest migrating, which impacts the land, grazes non-selectively, dungs, urinates, and then through migration moves on. But obviously you have territorial animals that stay behind. So in terms of grazing management, I believe the most important aspect is the high impact and non-selectivity of grazing, which improves the land. So even with animals staying behind, territorial animals, you will get a certain amount of overgrazing of grasses. In other words, the animals, smaller herds will concentrate in areas and regraze before the grass plants have recovered completely. So a lot of our grasses in Africa have also adapted to overgrazing. But what they haven't adapted to is no grazing and no impact. That's what's lacking. So high animal impact, non-selective grazing. On the left-hand side, you'll see a herd of cattle that is grazing at a stock density of 3,000 cows per hectare. So you can see on the left and bottom corner, you can see the impact, what that herd has done. And if you look at the right-hand photograph, it was 10 months later. So it increased, the amount of grass just exploded because of that high impact and instant fertilization, and then the 10-month recovery period. Well, this screen's not. So if I could sum up high density grazing, high animal impact, non-selective grazing, as many animals as possible in the smallest area possible for as short a period as possible, followed by an appropriate recovery period. Recovery period depends on environment. So in a very dry, arid environment with unreliable rainfall, you would need a very long recovery period, maybe a year, 18 months. In parts of the world, like in Mexico, the deserts of Mexico, they have an 18-month recovery period. But in the more humid environments, the recovery period for the benefit of the cattle would have to be shorter. So you have higher nutrition than grazing. If you have a too long recovery period, then the animals will perform very poorly. So it depends on environment. So we need control. If you need these high densities, you need control. And on the left-hand side, you can see herding. With herding, we can get very high stock densities and control of the cattle. And that would be very applicable in the many parts of Africa. And I think Rolf will be able to expand on that. On the right-hand side, we can also use electric fences. With my experience in many parts of the world, in most areas, you only need one electrified wire. If it's a drier environment at some stage of the year, periods of the year, you may need two wires. So it's very inexpensive. In fact, on my property in 1995, when I started ultra-high-density grazing, my total infrastructure required me to sell 5 cull cows to double my stocking rate, because in that environment, I was utilizing only about 50% of the grass because we were grazing selectively and looking at high animal performance. So 50% of the grass was never grazed. So just by doubling the number of cattle, we had enough grass to do that. And that was a process that started, and in 7 years, I could have quadrupled my stocking rate. Utilization of bush and grass, as you can see there, can be very high depending on how dense you put the cattle together. On the left-hand side, that type of browsing you get with cattle is, I've never seen it apart from wildlife, and probably even more than wildlife. And I assume the reason for that is because of time control. The tannin content is low when the cattle go in because of a long recovery period. And the cattle are out before the trees have reacted to the cattle being there, and the tannin content still remains low. So we're adding a very large, in particular in Africa and parts of South America, a large part of the diet of the cattle is by browsing, which I think has a very positive effect in terms of nutrients, minerals, and stuff like that. And also, it controls bush encroachment. And very fibrous grass on the right-hand side in the dry part of the year, that's a type of utilization you can get where a lot of the grass, probably about half, is knocked down by the cattle and not grazed, but it feeds the soil. Just a fence line contrast to show the improvement that happens. This is in Mexico, the dry part of Mexico, northern Mexico, which gets about 15 to 17 inches of rain. There's a fence line contrast on the right-hand side. The stocking rate after 2 or 3 years, I can't remember exactly, had trebled. The stocking rate was treble what you're getting on a conventional ranch in the area. And you can see what it looks like in the neighbor's property on the left-hand side there. There's no grass, just rocks and shrubs. And here you can see clearly the fence line on the right-hand side, where ultra-high-density grazing has been taking place for 2 or 3 years. And on the left-hand side, there's only a fence line in between. So it's a management on the right-hand side that creates what we have there. And on the left-hand side is the mismanagement that creates what we see there. It is a relatively easy matter to increase stocking rate. For a lot of people, that might sound far-fetched, but increasing your stocking rate is a relatively easy matter. The difficult part is to maintain body condition due to the fact that the cattle are forced to graze non-selectively. That is part of the process to maximize your profit per hectare. Even with a drop in animal performance, you're still getting much higher production. So the difficult part is to maintain body condition. And if you have cattle and manage them correctly, the right type of genotype, manage them correctly, we can increase body condition. And if we double stocking rate or triple stocking rate, we can double or treble your profit or your return on investment. Addressing body condition, we have to address body condition. The first one is genotype, the type of cattle we have. What we have done with modern performance testing, we select for growth and so-called feed conversion efficiency. We're selecting the animals that grow faster because they're larger, and they also grow faster because they store less fat. There's a lot more energy in fat meat than in lean meat. So what we've done is we've bred lean cattle that need better nutrition in order to be productive. And what we require are cattle the genotype that can maintain their body condition even under non-selective grazing. Grazing management, we can also modify our grazing management. We can decrease the recovery period in certain times of the year in humid environments where the grass grows very fast and loses its nutritive value. And you can do it on an area of your property. For 1 year, graze very intensively, maybe return after a month or even 3 weeks during the most important period of the cattle cows program. In other words, just after calving and before and after breeding. So we can do that by returning quicker before the grass is recovered, but we have to do it non-selectively. And by doing that, we will still improve the grass composition. But if we do it selectively, we'll start decreasing the more palatable, more productive grasses. Another thing in terms of grazing management is at certain times of the year, particularly the dry season, we can have a small herd of very high requirement cattle like your heifers calving, and they can graze ahead of the main herd and just graze selectively, and the main herd follows immediately behind. Another very important aspect is to calve, breed, and wean during the period of best nutrition. That's basically calve and breed on green grass. And if it's necessary, we can wean the calves at an earlier age to allow cattle to keep the cows to keep their body condition. And then, of course, rumen supplements are very important. We have to give supplements in mainly protein or non-protein nitrogen to allow the rumen microbes that digest the grass to increase the population. And you can see that by looking at the consistency of dung. If dung is very relatively sloppy before it gets to the French loaf stage, then the rumen functions correctly. If it starts getting very hard and compacted, then we should have supplemented earlier. So that's very important. What is the main driving force behind selection? Man or nature? Scientifically improved, in inverted commas, cattle that are selected for growth rate and high production are lean because of the reason I gave you earlier, that if cattle grow and they deposit more fat in the body, in the tissue, then they require more energy to do that. So if we're selecting for growth rate, obviously we're benefiting the cattle that grow fast because they're leaner and because they're larger. And that requires a high input requirement. On the other side, when we allow nature to do the selection for us, it's a question of survival of the fittest. And body condition fat is the main reason why animals can perform well under those conditions. And that is what we require for when we're doing high density grazing, non-selective grazing, and a lower input requirement, which helps obviously our profitability. Man must measure is a slogan that was developed by Johan Zietsman. The question I ask is, measure what? What do we measure? On the left-hand side is a facility where they test cattle for feed conversion efficiency, which means they have a certain feed available to the cattle, and their equipment there that allows the input, the amount of feed eaten to be recorded, and also obviously that is equated to the growth rate. So it's the amount of feed required for a kilogram of growth rate. So you might have one bull requiring only 4 kilograms of high energy feed for 1 kilogram of gain, where another animal that's earlier maturing, fatter, might require 6. But that energy is not inefficient energy usage, because that energy is stored in the body of the animal as fat, which is again is a reserve for the dry period. So as you can see there, what we're doing is we selected cattle that are efficient, so-called efficient, but they're lean. And we require cattle that put on body condition or inherently high in body condition. And if you look at the right-hand side, the EPDs and all the measurements they take to currently are completely inappropriate. How can anyone in his right mind use all those figures and put them together in a sensible manner? So I can't really read at the top of the screen. I'm not quite sure what it says there, but not everything that can be measured counts. Not everything that counts can be measured. So we have to rely more on common sense. Who has the greatest knowledge? Animal scientists or the herdsman? And I think that's a subject that everyone needs to think about. I believe that in certain aspects, the herdsman has got far greater knowledge than an animal scientist, because the animal scientist looks at detail and the herdman sees the whole and has a better perspective of the whole. For instance, a herdman can see that certain animals will lose body condition and won't reconceive. Other animals can do it. So, but the animal scientist doesn't see that. he relies on other measurements. And the herdsman often poses the question is, why do they select bulls as they do that breed animals that require more feed? Whereas in the herd that he's herding, there are animals that keep body conditions without much feed. 6 decades of performance testing, I'm talking particularly in terms of what's been happening in South Africa. Are the scientifically improved breeds more productive on the veld than the unimproved breeds? In other words, the common breeds, the conventional breeds we have today that have been performance selected and selected for growth, are they better on the veld? Are they more productive than the unimproved breeds, in inverted commas, which I refer to our indigenous animals that we find here in Africa in particular? And my answer to that question is by far greater productivity from the local breeds. And this has been recorded. This is an experiment they did in a trial they did in Namibia over a 14-year period, I think it was, but I'd taken the figures for the 1990-year drought and production per unit of land. So they compared, in this case, 2 breeds, the Bonsmara and the Nguni. The Bonsmara I take as an example because has been under performance testing for the longest time. And the Nguni is one of the indigenous breeds. So in terms of production in terms of fertility, the Bonsmara reconception in the dry year was 63%, and the Nguni was 79%. And total weaning kilograms per unit of land for the Bonsmara was 4,462, and the Nguni was 1,000 kilograms more, 5,565. So it's very obvious that our indigenous naturally selected animals are far more productive on veld. And it's even been proved by the scientists. Yet they continue with their program of selecting for performance. And here is another one example that in the South African system of performance testing for bulls, the phase C, they measure growth rate and they also measure the so-called efficiency of the feed conversion, which in this case is a high energy feed. And they put the animals in certain merit groups. Gold merit, obviously the ones that grew fastest and at a better conversion rate, down to silver, bronze, then sub-merit bulls. Those are the ones that performed, in their opinion, poorly just before slaughter. And they got a class at the slaughter as well. Now, the difference between the best, highest merit group of bulls, their females, as opposed to the lowest merit group, the females had a 5% higher calving rate for the lower group. So why are the breeds subject to ARC performance tests not the most fertile? And the reason is that the bulls that have a so-called better performance are because they're leaner. They don't require the same amount of energy as the bulls that store energy, which is the lower group, because of the measurement. That's the only reason. Nature is complex and very simple. We can take the complex route or the simple route. The complex route entails measuring detail, as much detail as you can, most of it inappropriate, and then trying to put that together and comparing animals on that basis. Or the simple route is where you measure the actual output. You measure the fertility of the cattle, but in particular, and also the relative growth rate, in other words, the maturity rate. The smaller animals be faster maturing. So in the simple way of doing it is to measure the output, not try and guess which details put together will give you the best output. How can any man put this detail together in a meaningful way? It's impossible. Assess the outcome that reflects detail in the appropriate relationship. In other words, we have to read nature correctly, what nature is telling us. And here in this case, on the left-hand side, I find is very important is to breed your heifers at an early age, and then you define which ones can calve at an early age of 2 years and reconceive again. And from that group of heifers, you select your bulls. And those bulls you identify also in terms of full package. I'll explain that later. The fuller package, in other words, that means a bull that's grown fastest relative to its frame size. So if it has done that, it is very more grass efficient. the highest yearling maturity, and or the weight in kilograms divided by hip centimeter. I'll explain that in more detail a little bit later. So we have to remember that cattle have been created to convert grass into beef and not grain. What we're currently trying to do with selecting cattle on growth rate is trying to make a pig out of them. But cattle have been created to convert grass into milk or beef. Four foundational traits are grass conversion efficiency and hormonal balance. That's the basis of the genotype of any animal. And apart from that, on that basis, you can select for other attributes as well. But that is the foundation, grass conversion efficiency and hormonal balance. And grass conversion efficiency will be reflected in inherent body condition. The contemporary animals with the best body condition are the more efficient grass converters. And the reason for that is the relative intake. And there's a big difference between small frame cattle and large frame cattle. For instance, a 300 kilogram cow, frame in terms of frame, as opposed to a 600 kilogram cow. The smaller cow will have a lower absolute intake of grass, but a 20% higher relative intake. In other words, a 20% higher intake relative to size. And that will be related to a 20% better body condition. So frame size is very important. And if you look in any herd, you'll always find that the smaller frame cows are the better body condition and the more fertile. And even between species of animals, you compare sheep with cattle. The small frame sheep are far more efficient. And if you look at animals, wildlife, there's a big difference between elephant and mice. Elephant has a very large absolute intake, but a very small relative intake in comparison to a mouse. And the mouse obviously is far more reproductive-wise, etc., is far more efficient than an elephant. So frame size is important in terms of intake, climatic adaptation. Animals that are climatically adapted will eat more. Animals that are parasite diseases will eat more. And also you have individual appetite. Individual animals, regardless of their frame size adaptation, will have a higher intake. You'll find some cattle that they just graze more aggressively and for a longer period of time. So that's all related to genotype, genetics, and you can select for that. And then hormonal balance is the balance between sex hormones and growth hormones. So if you have an imbalance, if you have more growth hormone, you'll have large animals and they'll be later maturing and they'll be less fertile as opposed to the early maturing animals in terms of frame size. Inherent body condition, an animal on the left-hand side, this is in America, where they have unadapted animals in the Midwest and the southeastern part of the United States, where it's very humid in summer, and these animals just can't handle those conditions. And basically they stand in the water for most of the day or in the shade. Whereas on the right-hand side, just by introducing, this is in Mexico, just by introducing some African breed blood, you have a completely different animal that's highly adapted and very smooth and good body condition. In this case is the Mashona cross Angus. Hormonal balance, highly fertile cow on the left-hand side. You can see her body conformation shows that. She looks more like a dairy cow as opposed to a subfertile animal on the right-hand side that's been selected for growth and has a hormonal imbalance. She grows, but she's very late maturing and very, she's subfertile. She has a low estrogen level. Same with bulls, hormonal balance. Left on the bull on the left-hand side is masculine, and the one on the right-hand side is effeminate in the same herd. You can see just by the conformation of the bulls, the more fertile bull is he's got a very heavy, deep chest. He's got coarse hair on his neck. Obviously, his testicles are much larger than the bull on the right-hand side. And the article that I took these photographs from was relating to the fact that the modern type of animal is required to be faster growing and larger frame. And that's what they've got on the right-hand side. So if you select for frame size, you select for hormonal imbalance, which you can see there clearly in that animal, and particularly looking at its testes. The same animals from behind, You can see on the left-hand side, the very fertile bull, shorter in the leg and very much wider through the thighs, which is a masculine trait. Whereas the one on the left-hand side is wide through the hips, which is a feminine trait. So we have to be very careful of that, and that's a foundation. The animal on the right-hand side, there's not much chance of his progeny being very productive and giving you maximum profit per hectare. So conventional selecting criteria: average daily gain, weaning weight, yearling weight, absolute weight, feed conversion efficiency are negatively correlated to the foundational traits. In other words, to both hormonal balance and also to inherent body condition. And the reason for that in terms of inherent body condition is that fat meat contains more energy per kilogram. But if you measure it incorrectly, you will measure the animals that grow faster because they're larger and they've got less energy in their meat. I'm not going to spend too much time on this, but it's very important. What I've done is I looked at the feed requirements for different size animals, the top 2, 3, 4, 500 kilograms, and the daily gain 0.2, 0.3, 0.4, 0.5. So what's interesting, this is the energy required for 1 kilogram total of gain. So an animal gaining 0.2 would require 5 days of growth to be able to gain a kilogram. So if you look at the figures in red, those give you all the figures in front of you give you the amount of energy required per kilogram of gain. So if you look from left to right, you will see that the larger animals require, for the same growth rate, 0.2 kilograms, for instance, require more energy per kilogram of gain. And if you look down from top to bottom, you will see like a 200 kilogram animal. The faster it gains weight, the more efficient it is. But it doesn't mean to say that the fastest gaining animal is the most efficient. If you look at these figures in red, those are equally efficient. But to be equally efficient, an animal has to grow in proportion to its size. For instance, 200 kilogram, in this case, requires 0.2 kilogram of gain. A 500 kilogram requires 0.5 kilograms of gain to be equally efficient. So 165, 160, 160, 164 denote equal efficiency of gain. So what this means is that fast individual gain is positively related to efficiency. The faster an individual animal gains weight, higher intake, above maintenance, the more efficient that animal is. The small individual is more efficient at similar weight gain. In order to be equally efficient, and individuals of different size have to gain in proportion to their size. So the most efficient individual has the fastest relative growth rate relative to its frame size. In other words, the fullest package. But there is a problem. Although animals have to grow in proportion to the size, they cannot eat in proportion to the size. So larger an animal becomes, the more it eats, but the lower its relative intake is. Smaller frame cattle have an unfair advantage. Large frame cattle are genetically handicapped, no matter what the conditions. So the package what I'm talking about is indicated by this bull here. The fuller the package, the more efficient the growth. In other words, the package indicates that an animal relative to its size, frame size, has put on more weight, has grown faster relative to its frame size, and so the body is fuller. So we just have to take a visual assessment of bulls. We don't need all this complicated measurement. We can, the simple measurement would be to weigh it and take its hip centimeters at a certain age. In other words, a group of bulls at yearling age, weigh them and divide it by the hip height. And the one that's got the highest ratio is obviously got the fullest package. And currently these what they call pony type bulls, as you see on the right hand side here, are bulls that cull. They don't keep them, particularly the Bonsmara breed. They cull all these bulls that are so-called pony type, but that's the most efficient bull that we require because it's relative to its size, it's grown fastest, it's more efficient, and also because they're earlier maturing sexually, the frame size is smaller. So that indicates results in a fuller package. Of inherent body condition and hormonal balance. full package. You can see the left-hand side is a full package bull. It might be a little bit lighter than the bull on the right-hand side, which is a massive animal. But look how empty that package is. Understanding practical versus academic fertility. Breeding or feeding for fertility. Hormonal balance and body condition. So breeding and feeding. You can see these are two cows that calved at 2 years of age, but it's unlikely that the one on the right-hand side is going to reconceive. So both have a good hormonal balance, as you can see in their conformation. One has good inherent body condition, and the other one has poor inherent body condition. So the deciding factor here is body condition. On the same level in terms of hormones, but the one on the right doesn't have the body condition as the one on the left. So it has a academic high fertility because of hormonal balance, but practically low because of poor inherent body condition. So if you needed that animal to reconceive again, you would have to feed a lot more than the one on the right, left-hand side. So we select directly by using genetically discerning criteria. And females, calving at an early age and reconceiving, those that can calve early, 2 years, for instance, and reconceive again, that becomes the nucleus of your breeding herd, for your bull selection herd. And the bulls are selected on yearling maturity, and then you multi-side the bulls. In other words, at that age, some bulls will be able to produce more calves. If you can identify those bulls, and you can accelerate the process of natural selection by using AI from those bulls. The best that scientific selection has done is to breed cattle that require greater inputs in order to be productive. But we need animals that can be productive under poorer conditions. The best that can be done is to read nature correctly. In other words, let nature do the selection for us. Select appropriately and accelerate the process. So natural selection in order to maximize profit per hectare. Professors must start their careers herding cattle and observing cattle.
I love it.
Not a popular statement, but it's the truth. To all visit properties, implementing practices light years ahead of universities and agricultural institutes. So there are many farmers all over the world, and ranches all over the world, that are far ahead of what the agricultural institutes and universities can even think about. And composite breeding, as on the left, is not an exclusive club. 50 to 80% yearling conception in this particular herd by combining African breeds with a conventional breed like the Bonswara. The appropriate grazing management will result in 2 to 5 times stocking rate increase in general. And I think the poorer the land conditions are currently, the higher the redeemable stocking rate will be. Thanking you and acknowledging unimproved genotypes. So I want to emphasize this, is that we need these cattle to maximize profit per hectare. In other words, the animals that are considered to be unimproved, the naturally selected animals that can maintain body condition and, because of circumstances, multi-siring, have a good hormonal balance. And the real champions are those not selected by man. As you can see here, the extremely fertile cow on the left-hand side, very small animal, probably doesn't reach 300 kilograms. And there's a bull climbing up a steep embankment to find grazing in a very poor environment. Thank you very much.
Wow, wow, wow. Wow, thank you. Thank you so much for that. I'm sure there are, again, a whole bunch of questions about what you've just shown us, because it kind of sounds, you know, a lot of our breeding programs, as you said, in Africa, a lot of our AI programs, a lot of the dairy programs, it's all about knocking out our indigenous animals, bringing in a whole bunch of exotic breeds that don't do very well here.
Absolutely. It's a big problem, Sue. And you know, I've traveled around the world, and I've never seen better cattle in terms of the requirements for the environment than what we have here in Africa.
Exactly, exactly. And I was just thinking, I just noticed that John Logan is in the chat there. Mayan Kwele bull is up on his farm. And that bull made it, because of the fat on the bull, made it throughout the entire drought where a whole bunch of animals passed away. But that bull is standing today. He's got good genetics, he's got, good resilient genetics. And, we, like you're saying, when we read our animals, when we read nature, it's, we're going to come to far better, logical, sustainable, and profitable conclusions than if we go to the AI tank and take a straw out of an animal.
It's not about production as such. It's about production relative to intake of grass and inputs. Most of the AI today is done by using hormones and synchronizing cattle. But if you do it individually on individual heat spotting, and your heat spotting is good, then it can be very effective.
So what is heat spotting, for those of us that might not know?
Well, when the cow comes on heat, when she cycles.
Okay.
And then there's a certain period in that cycle that you inseminate her, and it can be a very, very highly productive. I got over 70% with one insemination in calf conception rate, which is very high. But that is because I did individual spotting, and not the expensive and easier way for the vets to synchronize cattle and come and inseminate them in one day.
Yes,
that's
being done. Well, Johan, I'm going to move on to our next presenter very quickly, because we're going to have a little bit of a panel discussion here with everybody. So thank you so much for that. Totally appreciate it. And keep your questions coming in the chat. Our last practitioner, from a long family of conservationists in Zambia. He's a co-founder of Grassroots Trust Ltd, a company working with catchment communities in Zambia and the region, building capacity in regenerating natural resources and economies through improved management. He's a firm believer in creating sustainable ecosystems of stakeholders to mobilize collective action, and will share his experience with ultra-high density strip grazing in this context. So over to you, Rolf Shenton.
Thanks, Sue. I hope you can see my screen there.
Yes, we can.
Okay, so yeah, that's a hard act to follow, those two geniuses there. I realized some time back that the technical stuff is, it's so obvious now for me that sometimes I forget that people don't think about it. So I have to do some of that. But mostly my job is about mobilizing people to see the future, to see the kind of lives they want, to see that they're going to have biodiversity, to have growth, to have abundance, to have health, wealth, and peace, and have a viable future. And that's got to be on the forest side of that, or going towards the forest. Of course, if the forest canopies, then there's no light coming in, and you're not going to have anything. So it's just behind the extreme left-hand side of that picture, and where we've been sprinting for the last, especially for the last 100 years or so, is reductionist management, which is reducing all that, keeping it simple, going to monocultures, putting very simple pastures down, and basically we're sprinting towards desert. So it's to try and tie people into having a vision about a long-term sort of goal about having a good future. And for this to happen on a catchment basis, we've got to try and ask the questions about the current management, which is, why do herds of buffalo and other wild animals not destroy their lands, their grasslands, like our cattle and goats seem to do? Why do wild herds not get too many ticks and disease, like our livestock do? And how did people keep so many cattle together with lots of wildlife and no dip, no vaccines, no vet? And we've got a big problem here with people spread out and not living in big communities anymore and not keeping one big kraal anymore. They got their little kraals all over the place, and there's a big problem with livestock entering crop fields. And that's the basis of most of the conflict up, I think, around the Sahel, with big herds of cattle coming through and disturbing crop fields. So it's necessary to try and get people tuned into this, and those are the kind of questions we ask to get them thinking about this. So it's really about trying to get people together and say, okay, how do if we got all these little herds all over the place, what are the incentives to put your animals together? And it's not easy, I tell you. We've failed many times to convince people. They can see the logic of it. They can see the sense in it. Everybody's got small little bits of land. If they put all their land together, they can manage it much better. They can take the cattle into areas where there aren't so many crops, or there are no crops when there's crops in the field. So that's the real practical part of this, is to try and reduce the conflict between crops and cattle. And that it's tricky, we don't trust each other that much. We don't trust that guy to look after our cows this month or this week, and then he hands them over to the next owner, and the next owner is going to look after them. But we have to sort of build trust, and trust is the real commodity here. So building trust and having that common shared vision is really for me, the most important part in the beginning, is to try and get that going. Of course, there's commercial things that can come in, but generally people around here keep cattle for no other reason than keeping cattle. Just having a lot of cattle. Many communities here will tell you that they don't sell cows, and all they want to do is maintain that number of cows. But at the same time, the need for money comes more and more. The school fees. So trying to help people look at, factor in the financial needs of their families and their needs is an important part of what we do. We just try and do some simple sums and just show people that if you can increase the productivity of your cattle, you could actually sell some, and your numbers will still remain the same, or they can even keep growing. Productivity is really low, and of course opportunities for disease are getting higher and higher as body condition decreases, as catchments become desertified. There's obviously two ways of dealing with this. The government the conventional way to deal with this is to keep reacting to the symptoms and put more dipping in and more vaccines and try and address this. But you're just going down a rabbit hole, because you never get on top of it. Every time you dip, some of the ticks going to survive, and they'll be back with a vengeance. And there'll be more resistance to the cattle, to the dip you're trying to do, that you're trying to put across. Vaccines can help for sure, but you've got to ask yourselves, 120 years ago here on the Kafue Flats, which is one of the big wetlands in this part of the world, we've got the Barotse Plains out in the west, and we've got the Kafue Flats, where there were estimated to be 1 million cattle 120 years ago, to the turn of last century, and about between 3 and 9 million wildlife, all migrating. People had learned that if you move the cattle with the wildlife, they'll stop they'll break the cycle of disease. So you'll leave the ticks behind, and by the time you come back next year, the ticks are dead. They're starved. There's always a few, because there's always some animals that stay, but generally that was the general thing. It was a big migration off the plains as the floods came, and then back into the plains as the floods receded. And that cycle was broken partly by damming the rivers, but mainly because people broke up their big communities and stopped working together and started now settling on smaller portions of land. Many plots are not suitable to keep as many animals as they had, so they're overgrazing. They don't have enough water, and it becomes a very chaotic scene. And that's what we try and do, is try and get back into that community, ask them what they were, how did their grandparents used to manage these cattle with all this wildlife. Today there's very little wildlife left. We've got about a quarter of the cattle left, and about 3-5% of the wildlife left. And now, of course, everybody's blaming the wildlife for passing on the diseases. Whereas 120 years ago, people were actually taking their cattle to the buffalo. The story is that they may crossbreed, but the real logic of it was to expose them to the diseases that the wildlife were carrying, the foot and mouth and the corridor and other CPBP, and build immunity in your herd. And today it's completely the opposite. I hear that Zimbabwe now wants to fence off all their wildlife areas and try and keep the diseases within fenced areas and don't allow them in. But you're just setting yourself up. If you lose your natural immunity in this part of the world, you're setting yourself up for a big fall, because you don't need much you just need a broken fence and you've got a big problem. So we struggle against policymakers, we struggle against modern scientific reductionist way of thinking, treating the symptoms. We want to deal with the root cause. And so it's a job. But of course, people can see that if you put your animals together, all these kids that are looking after the cows today, they can go back to school. And, 7 herders can look after, in our experience, 2,000 cattle in a group without too much problem, and that costs less. The cost of herding gets really low, and also it becomes so much more efficient because you can train those herders. They start understanding that herd becomes a tool to restore the land, and once the herders are into that, they get so excited. We've seen that in our own communal herd in Impansha, where we've got 520 animals, 67 owners or 57 owners, and we've got another 300 sheep and goats, which for time being we've separated because there's just not enough browse to keep the goats happy. The trees are too big, actually. We need to cut the trees. But anyway, there's just not enough browse, so we've separated them for the time being. But mostly we're running the 3 species so that you're simulating those natural herds, and you're cropping the whole system. You're getting much better bull to cow ratio, as Sally was talking about there. We got 5 bulls to service 500 cows, and there's no problem with bulls, cows finding bulls at the right time. They're always there. Of course, if you've got the community spread out over hundreds of little plots, people tend to want a fence, and this ends up costing the community a lot of money. In our case, we're really trying to reduce that to just 1 electric fence for a night crawl. We try and persuade people to move the crawl as often as they can, so we move the crawl every night, and that gives us very little risk of any disease recycling. And we use that crawl we look for a bare patch and we put the crawl on there. We use the night crawl as a tool to restore the land. Most of the time we're in the Zambezi escarpment, which is part of the Rift Valley. It's the Zambezi Luangwa escarpment, very dry, arid, hostile territory. So we're herding. We have to herd because it's so inconsistent. The land is so inconsistent. You may be down in the wetland at the bottom, the little ravine, and then you're up the mountain and there's very little to eat. So you've got to adjust the speed all the time, and make sure that you're keeping an eye on the animal health primarily. And bit by bit, we're seeing the land heal. Of course, we've had to get adapted animals. So we took the smallest little animals we could find in the Zambezi Valley, some that had survived the worst management and the harshest conditions that we could find, and that those ngonis form the basis of our herd. We've tried to bring in, there's tsetse fly where we are, so we do a bit of samarin, but we're trying to reduce that. We're trying to breed as much resistance for everything as we can, and it's working. We brought a Baran bull in, and he was dead within a week, and that's a fairly adapted animal. Obviously, hadn't never been with tetsis though. So we're in extreme conditions. 650 mils is the normal rainfall, but it goes down to, the last few years have been 300, 350, 400. So we have some really dry periods. And drinking water is always our main concern. Again, if you put everybody together, we can afford to dig for water, drill for water, make little dams to try and catch some drinking water before the land is really functioning properly again. And we expect that land to heal, because we can see that gradually the streams are beginning to flow better. The whole function of the ecosystem is improving bit by bit. So we've been on it for I think it's nearly 7 years now, and things just get better and better all the time. Productivity, of course, we've brought in 57 different owners. Somebody's got one cow, and we can't really refuse it. The only condition is got to be a local breed, and we put it in quarantine for a couple of weeks just to clean it up, make sure it's not going to infect the herd. And once it's in there, but it's very difficult in that communal herd to select your better cows. So our productivity is about 65%, and we're looking for ways to get rid of the non-productive cows and start really getting that up. We think we can get up to 90% quite easily if we can get rid of the rubbish. But that means we have to really find a way to compensate everybody. So we're moving towards a corporate model where everybody puts in their cattle to one corporate entity or one entity cooperative and take shares. And then we can get rid of the rubbish. And it's much lower risk for everybody. And yeah, we're trying to move that way. It's very complex. How do you compensate people fairly? But in the end of the day, I think the communities in our part of the world anyway, they need another model to keep these communal herds. The traditional model is breaking down. A lot of people still own cows. They've moved to town, and they keep on getting stories from the village that, oh, your cow died, So we've got to come up with a more efficient, more business-like or organized model for that. And I think we're cracking that in Mpancha. We're seeing a lot of communities take interest around the country. We campaign it hard, and we just try and ask simple questions. People say, well, we haven't got enough land. Well, if there's 200 of you or 50 of you putting your land together and you're managing it as one, then you'll find you've got more than enough land to separate it from the crops when they need to be, to come back into the croplands, to fertilize the fields when they need to be. You can really manage it much more efficiently than if everybody's trying to do that on their own little shambas. So there are a lot of incentives. Of course, marketing is another one which can really be a big pull. At the moment, somebody runs out of cash. In January, the cattle aren't very fat, but they need the cash quick, so they'll take one cow out the herd and walk it to town. Maybe it's 40, 50 kilometers. By the time they get there, they've got no negotiating leverage. They get the lowest price because their cow's about to drop dead, and there's no way they're going to take it back because the price is too low. So they get the lowest price. Things get, by the time they've got it there, it's in the lowest body condition, so we get the lowest grade. So there's a lot of room to improve that. If we can get a community to put their animals together, put them on a separate pasture, and invite the buyers to the community, we suddenly have very much higher incomes from those cows. And so these are good incentives. It's much easier to plan together, of course. And what we're seeing as a secondary sort of benefit here is the forest improves. So we've seen over the last 7 years, nearly 7 years, in the Mpantsha herd, that we've got a load more mushrooms now than we had, a lot more leaf plants, the spinaches that people collect in the forest. The fruit seems to be doing better. So now we're building another economy on the back of the cattle. The cattle are healing the land, and the land is getting more fertile, more richer, and the plants are getting more productive. And now we can see that there's a very big business collecting all this stuff, aggregating it, maybe value adding it. So we're working on that, and that's very exciting because, you know, people have given up trying to collect forest stuff. Basically, people just burn the grass here in Zambia. And we're just saying to people, look, if you can get your animals to it before it burns, you're going to make money. If you're going to let it burn, it's going to make smoke and heat. And, you know, we want money and meat. So, yeah, we do a lot of soil tests, like I saw on the Chip's pictures there. Ours is very simple. In the crop field, we'll go into the crop field, pick up some soil, and look at the color, the texture, and the smell. And then we walk into the bush next to it. Maybe 2 meters away, you can find a little bush or something, pick up the soil, and it's dark, and it's got structure, and it smells like money. And that's what we try and look for, those simple things that the water test that I think many people do around here, just to show the infiltration, how quickly the water will dry up on bare soil compared to covered soil, and compared to impacted soil, which is covered. You know, your infiltration really improves. And I think, you know, water is one way we can start unifying people around this collective action to try and heal the land. So I think that's all I've got for now. I'm happy to carry on answering questions. Thank you very much, Sue, for this opportunity. And it's a great honor to be with those other two speakers.
Thank you, Rolf. Thank you so much for sharing your story. And I'd like us to bring all of the others, so Johan and Chip, into the middle now. We'll have a little bit of a panel discussion around what we've seen in the 3 presentations. They're all very diverse, they're all very different, but we're all talking about the same things. We're talking about regeneration. We're talking about regeneration being the basis of survival of our different genetics, survival of our custodians of the land and of the livestock, and also, you know, survival of ourselves from a nutritional perspective. So, Chip, I saw that you've got some questions there, and I'm going to just leave you to ask questions to each other for now, because I'm sure you've all got a lot you would like to pick out from the presentations you've just seen. So, Chip, why don't you kick off with the question that you had there about, well, you have them in the chat there. Go ahead.
Thanks, Sue. Johan, looking at the selective versus non-selective grazing, this is something that my head is having a hard time getting around. I would tend to think that once soil health is improved and grasses are more productive and more nutrient dense, we know that short-term high-density grazing, if it's short-term enough, will stimulate more biomass production and if they're going after the palatable species, my small mind tells me, well, then that's cool. Let them go after that, stimulate them, pull them out, move them on, and we'll get more growth of the palatable species. And the overgrazing that's been just at least dramatically, I would say catastrophic in our East African rangelands, has created the opposite, where the non-palatable species grow more and the lower nutrition ones.
Well, basically, the big problem with current management is selective overgrazing at low impact. Selective overgrazing, so your more palatable species will decrease. And also the impact has a positive effect on the soil if it's time controlled, knocking down material and breaking up the soil surface. So if we do the opposite of a conventional management, we're going to get the opposite results. And I've got data that I've documented on my own property where the species composition changed very, very quickly over a very short period of time. I have a relatively high rainfall, 40 inches, 1,000 millimeters. And with the change in grazing management, it just happened overnight. In fact, one of my monitoring sites, I had 4.5% what I would call palatable species of grasses, which are also more productive. They recover very quickly because they've got a strong root system. But if they continue overgrazed at low impact, then they decrease. So on the one monitoring site, in 1 year, it changed from 4.5% palatable, semi-palatable, to 26% in 1 year.
Wow. Wow.
I've also changed that in a very quickly, because initially I had so much grass. I grazed at a relatively high density and I moved 4 times a day, but I didn't force the cattle to eat all the grass. And then it changed again in 1 year from 26 to 10%, just in 1 year. So I find the more palatable, more productive grasses are the ones that are being favored now with the high density grazing, as opposed to the less palatable grasses, which are also the poorer root system, I believe.
Which is stimulating them to grow more as long as you don't keep them on that ground too long.
Exactly, it's about time, but it's about competition, you see. So if you create the conditions, the grasses, the more palatable grasses, more productive grasses require better soils. So if that is what you're creating, then they will increase.
Yeah, we got a lot of indigenous species come up, and some of which even experts we brought in from the outside didn't recognize, just by improving that soil health.
Yeah,
exactly. It's all about the soil. It's all about the soil.
Yeah.
And time.
Yeah.
Right.
I'm just going to jump in with a question again, just about diversity and resilience, but not about the plants and the soil here, but about selecting for those the cattle that you were talking about and that we saw when I was with you in Zambia, Johan, and we were looking at the ticks. And it was interesting how we could see some animals that were just loaded with ticks. And conventional thinking is, dip that animal. That animal is like, it's gonna create a disaster. They're like a magnet of ticks. Talk to us a little bit about that, about when you're looking at resilience and ticks in your cattle. What are we looking for, and what is actually good? Because I grew up in a ranching family where we had to dip by law our cattle every week. Because what happened after the Rinderpest, we imported cattle from Tanzania, and they brought East Coast fever with them, which we didn't have. We had tolerasis, but not East Coast fever. So the authorities forced us to dip every week. It was illegal not to dip every week. But we had a plunge dip, and occasionally a calf going through the plunge dip would just about drown. Well, maybe one in 200 calves would have that problem. So we'd pull that calf out, put an ear notch in its ear, and it came back to the dip every week and never ever dipped. Those calves became cows that had never dipped, came to the week every day, no ticks. The ones that were dipped every week came to dip with ticks. So that was a mind opening for me. You see that with cattle, nature is so perfect that animals are born with a pre-immunity. Calves are born with pre-immunity to most tick-borne diseases. So if you don't dip them, they build up their immunity. And if you start dipping them again, they lose the immunity. So you have to have ticks on them all the time to keep that immunity. So not dipping them allows them to keep the immunity, but also by not dipping them, the mechanisms in the body, and I think this is a lot to do with epigenetics, is the mechanisms in the body trigger a reaction
and expel ticks and decrease the tick population on the animal itself by not dipping him. And the other very important thing is body condition.
Yes.
If you have cattle in good body condition, they were able to maintain their health much better. I have cows. I have cattle in Zambia that I haven't been here long. I've got a herd smaller. I've got cattle 2 years old that have never dipped, not once. The only problem is if I introduce other animals, I might have a problem. So I've got to be careful about that.
Yeah.
But they keep their immunity up, and if I keep the body condition up, they will not succumb to any tick-borne disease. But if you dip them, they will.
Yeah. Interesting.
I agree with that, and you know, it must be many factors. We're breaking the tick cycle, so we really only have to dip twice a year, our communal herd, because they're just not recycling. But definitely they're also, you know, we can see the body condition is much better. When we bought them, they were like goats. Second generation were bigger, and third generation bigger. So we've proved that even the local breeds, if you feed them properly, they can get big. They can get, you know, fairly much bigger than they were anyway. So
I would say better body condition, not bigger. Heavier, but not bigger.
Better body condition, yeah. But you know, absolutely don't. Why dip if you don't have to? You know,
a lot of people say I never experienced in my 7 years of ultra high density grazing on my property in Croy. I didn't experience a drop in tick population. In fact, I think with my conditions here, the grass I had, I probably had more ticks. But because I hadn't been dipping my calves from 86 and only dipping them occasionally as you would do, I had more ticks, but I could see the difference in individual animals. Some never had ticks on them, and some had more ticks on them. So we can select for tick resistance as well. And that's what I would have done if I still had my property there.
Yeah.
This really reminds me of some crop farmers experiencing the journey on regenerative ag, where they pull back pesticides, and all of a sudden the pest burden decreases. And it's astounding. But it's the same thing with the plants in terms of immunity and resistance.
Yes.
It's also the same thing with the plants and the livestock. We've talked about epigenetics and the different changes that will happen with plants. When you start pulling away those controlling chemicals and pesticides and toxins, they begin to behave differently. You begin to see them differently. They express their genetics differently.
You see with sorry,
go
carry
ahead,
on.
John. No, please.
What I was going to say is with conventional selection, we are selecting cattle that become more susceptible to disease because of lack of body condition. And it reminds me of a sugarcane producer in Brazil. I don't know if he's a very interesting person. I can't remember his name now. He's got 20,000 hectares of organic sugarcane. Now for over 20 years, he's been producing it. But he had to go back to the old sugarcane varieties because all the new varieties of crops are bred to use chemicals. Fertilizer, pesticides. Exactly the same with cattle. They were bred to be fed and to be clean of any parasites. Whereas if they're good body condition, they can maintain parasites without getting sick.
I have to say though that it takes nerve to take that plunge. When we began 8 months ago, the surrounding farmers were using fertilizers and certainly pesticides quite a bit. So here we were starting on sand without anything except our biology. But you know, once you take the plunge and you say to yourself, "There's no looking back," you figure out how to make it work.
Yeah, we've seen a lot of you know, that being proved on. Sebastian Scott runs our cropping section and small farm, so it's just simulating the same thing, integrating livestock, mixed cropping, a lot of agroforestry lines. So he does a agroforestry lines and then rotates his crops between that. And he does not. The first thing we advise farmers: stop all the sides, all the herbicides, pesticides, and everything, because once those plants are healthy, I think it's Kempstra who's proved this in the States. They literally cannot be eaten, and the proof of that is just looking around you. They would, if insects breed much quicker than plants. So if plants could eat healthy, if insects could eat healthy plants, there would be no forest left.
Exactly, absolutely. And one thing that we're seeing, and that's really cool, and that's something that my team and I are putting together, is we're looking very closely at bricks and bricks readings, and being able to look at the sap of plants and be able to see, almost predict where your plants are and what kind of pests will attack your plants and how to move that bricks forward. So use bricks as a management tool, but also as a tool to create visibility and transparency of healthy food for consumers who want to buy something that's got more energy in it, more nutrients in it, that came from a well-functioning plant and not a sick plant that was kept alive by synthetics and cleaned up with pesticides.
Yeah. If I could say one more thing on that, if we think of this as using the cattle to grow a more diverse pasture, Professor Jealous here has been doing, I think him and I went to Johan's course some years back, and he's been doing high density for a while. He identified 65 new legumes in his pasture, and of course he didn't bring anything in. They just we're using the cattle to allow the land to express itself properly, and that gives the cattle much more diversity. And they do self-medicate, but if there's only a monoculture in your pasture, they can't self-medicate. They can't sort out their own problems. So there's a lot of stuff to be looked at there. It's very complex.
I'm extremely lucky in Zambia, because I think it was either Johan or Sally who told me that Zambia has got the highest diversity of legumes on the African continent.
Well, I wouldn't. I said that in all my travels, I've never seen so many legumes as I've seen in Zambia.
I think it was Sally that told me that actually the diversity, because there are so many different trees, so many different plants, so many different grasses, and the minute things start to recover, it just seems to be legumes that are popping out of the ground.
Yeah. No, Miombo has 8,500 species altogether, of which only 300 are trees. So the rest are shallow and medium rooted plants. It's incredible how many plants we've lost by losing our big herds and replacing it with fire, but we can bring it back quickly.
Absolutely, we can.
Do you find indigenous flowering plants or flowers returning more? Because some of the recent stuff I've heard or learned is that looking at places like the prairies in the States, they were not predominant grasslands. They were predominantly wildflower lands with some grasses.
Yeah, I would say that you got, out of 8,500 plants, you just see this, it just explodes into life, and you see all the families represented. Yep.
And just like you were saying, Chip, we've had some farmers here who have been doing, the organic farmers who are looking closely at soils and are closely using vermiculture actually as part of their extracts. There's a gentleman, he's 80 years old, and he says that in his entire life, he used to remember the plants that are growing now. He remembers seeing them on the farm with his dad when he was like 7 or 8. And he said, hadn't seen them for years. And suddenly by changing and letting the land rest and actually, putting biology back into land, he's seeing these plants. So it's amazing the resilience and the seed banks that are in there, just waiting to be given the right opportunities, right? Or waiting for the biggest pest, which is us, to get lost.
Absolutely. We did this. My team in the Sahel.
Sorry, I'm saying we are the biggest invasive species.
We did a similar thing back in sort of after you developed your technique and moved forward. And Alan Savory came into play more in Niger and the Sahel. we did enclosures and we grazed some and didn't graze others, and found exactly what you say. The seed bank is just unbelievable. And this was full Sahara Desert that we were in at the time. So if it works there, it'll work anywhere.
Yeah, it's very interesting. When I started, I had put up some permanent electric fences that I hadn't moved for a year. So I had 2 grazings there. And under the fence line where the cattle hadn't impacted, there was still capping on the ground. And after the first year of ultra-high density grazing, everywhere away from that fence line, we had new species of grasses germinating. Under the fence line, which was still capped, no grasses germinated, only weeds, what we call weeds.
That capping, I think, for us in East Africa is what we call hardpan. Is that right?
Well, it's more, no, it's just not it is partly a hardpan, but certain areas you get a capping which is created by raindrops or by...
It's the crust.
It's a crust, yes, yeah. So if you don't break that crust, anything that germinates there won't be grass. But if you break the grass, it's 100% grass germinating.
That's where livestock with their hooves.
Yes, exactly. So it just shows the conditions necessary for those grasses. They're there, lying in wait for the right conditions to germinate.
Yeah. Yeah. Wow, look where we are. We're at 21:59 and we haven't even taken any questions from, from the audience yet. Let's do that quickly before we close. We were supposed to be going till 10 p.m. So let me go to some of the first questions that we've got here. And those of you that have questions, please do put them in the chat because I'm going off the chat now. And I'm going to go to the first question, or rather it's a comment. Felix, thank you for that. Yes, regenerative agriculture is the way to go. And thank you for following today. Let's see. So Derek had asked, is the feed input efficiency, that's the FCE that you were showing about, the same as feed conversion rate?
It's the same, but the problem is that they're measuring it incorrectly because the feed is of equal energy, but the output in the meat is of a different energy concentration. So an early maturing fatter animal with the same amount of feed will convert into a greater amount of fat as opposed to meat. So the weight gain will be less, but the energy conversion will be as good or even better. And that's a problem. So when you're measuring that, you're measuring, you're benefiting or you're discriminating against animals that mature early, which are the animals that you require. So you are breeding animals that are leaner and require better nutrition in order to be productive. So that's not the type of animal that you require at all, and particularly with ultra-high density grazing, where you challenge the body condition through the non-selective grazing.
Yeah, yeah. Thank you. The next one is the indigenous breeds. This is from Chilekwa Kunda, who said the indigenous breeds are also very resilient to a lot of diseases and climate change. Thank you. You're absolutely right, which is what we're saying here, which is why we need to try to preserve them, preserve the genetics and the way that we're breeding going forward with our, our breeding programs. Chip, you asked about the average rainfall in Rolf's area. I'm asking on your behalf.
I think he defined it as about 650, if I recall.
Okay. And then you also asked if you've seen wildlife recovering as the grassland regenerates, because that's the other thing as well. I mean, the other thing that I learned about being able to do the kind of strip grazing that Sally was doing is if you're in an area where there's a lot of wildlife, it's almost impossible because you can't leave your animals out there at night, and you can't leave them in places where they're, you have to confine them at night. And that just taking, I mean, maybe both yourself, Rolf, and also Johan can talk about this. There must be also a big advantage to being able to eat throughout the night, to be able to eat lush and nutritious feed throughout the night, as opposed to being put in a kraal and waiting for the next day, all those hours before you go out to eat again.
Yes, that is correct. That is why particularly with the electric fencing strip grazing, it's much easier to just leave them sleep in an area and not actually crawl them. But the advantage of crawling is, as Rolf was saying, you can use that high impact on certain areas where they can sleep at night. And people have done it with croplands as well. Cattle sleep on croplands and fertilizers croplands maybe for a night and then move around like that. So there is a value in doing that as well. But it would definitely impact body condition of cattle. If they're allowed to stay for 24 hours, they would be in better body condition.
Yeah. We're definitely moving towards. I mean, obviously, if we're looking for a bare patch for the night, we're also making sure there's a salad bar next to it, so that they can graze into the night or browse. I mean, what we're finding is the tighter our animals are, the more they're going to browse, because they get very competitive. They get very. They have to eat whatever's in front of them, and in the beginning they didn't seem to browse at all, and now we're pushing them. They browse much more, and certain times of the year they're basically just browsing because there's nothing left. Somebody's burnt the area, or there's no grass. So that competitive thing I didn't mention, but it's really important. We call it lazy animals. So if you look out most communities, you're going to just see these lazy animals just wandering around, selecting. And you put them together and they just get this communal energy, and they eat much more in a day. They eat vigorously.
They have to, yes, exactly. That's true.
Yeah. But we do it as humans too.
Yeah.
Another thing I think it happens, Rob, is with the timing, the tannin content of the leaf is much lower. Because in an area, short period of time. So that you're familiar with how the tannin defends leaf bushes.
Absolutely. I watched the giraffe.
Yeah.
And that's just so amazing. So Johan, there's one question here for you. We'll take this as the last question for the day. It says, Johan, in your experience, is it possible to breed a Feldmaster type dairy animal with some Holstein genetics to manage in a high density grazing system? Or perhaps,
absolutely.
Sorry, go ahead.
Yeah, absolutely is, but I wouldn't go for the Holstein. I would go for the Asian breeds that are producing milk, like your Sindhi, which are far better adapted, and also your Gur. So we could use them. And in fact, I'm going to breed a herd of my own, more tropically adapted and more dependent on grass than feed.
Yeah.
So yes, we have to.
And what's interesting about that is the Africa Dairy Genetic Gains Program is looking at that, is looking at which are the tropically adapted animals that we should be crossing with. And one of the herds down at the coast, it's Makitosha Farm, has done that. They've done gear crosses across a whole bunch of different exotics and also others. She's got animals that are eating garbage, literally, not garbage, but I mean the feed that they're getting. A normal dairy, an exotic dairy would not be able to produce anything, but these animals are producing amazing amounts of milk. But she's also got an amazing amount of historical data of the crosses that don't work. And that's important also, because it takes time to work through the crosses to get the ones that do work, which is very cool.
If I can ask one more question for you guys, because you're just so full of information. One of the things we've got anecdotal evidence for and haven't done the analysis yet is when we're growing our biology, we found we need 2.5 to 3% goat manure to provide nitrogen that steams up these piles for our thermophilic phase. Whereas in Nairobi, we were at 27% goat manure. And what we're using for our other substrates are basically a lot of bush and shrubland and leaves. And my feeling is I'm thinking that possibly the trichomes on the leaves are fixing nitrogen. So basically these are leguminous bush that may not be regularly recognized as such, but then could potentially provide far better nutrition than perhaps grass may for livestock. Does that make any sense, or am I out to lunch?
Well, it does make sense to me. The things that I experienced with ultra-high density grazing, I could never have believed would happen if I hadn't done it myself. One instance is that earthworms. I'm in a seasonally dry area with 8 months without any rain. And after 2-3 years of ultra-high density grazing, I had earthworms all over my property.
Amazing.
Yeah, I think also the nitrogen, Seb's getting 16 tons of maize, up to 16 tons of maize without any fertilizer for 22 years. And his secret is to keep, in this part of the world, your nitrogen's all going up in the air. It's volatilizing. So keeping the manure in the ground or getting it there, if you've got a good ecosystem, you're going to have a whole bunch of dung beetles doing that for you. And that's the trick. I just wanted to say that on the wildlife, we're definitely seeing wildlife coming back. They're moving out of the national park into our area because the whole vegetation is sweeter. And it's now becoming a problem because the lions are following them. So we're thinking about having tents now instead of electric fence at night.
Okay. Oh dear, it looks like Johan dropped out. It would be terrible to end this session without him in the call. But
I'm back. I think I'm back.
Oh, you're back! Yay! Well, I would like to end on a note about your book, Johan. So I read this book on the way back from Zambia. I bought it on Amazon. It landed with me the day before I went to Zambia. I brought it with me to Zambia. Thank you so much for signing it for me. It's very special. And I read it on the plane back cover to cover. And anyone who wants to continue this, it is a lot of information to absorb all in one go. And you can go over and over a webinar like this, which is why we've made it. But this is also a great book that takes you step by step, chapter by chapter, through all of the things that Johan has mentioned. It's available on Amazon. It's called Man, Cattle and Veld. And on that note, I want to thank you all from the bottom of my heart, all of you speakers and panelists. So Johan, thank you. Rolf, thank you for joining us. And Chip, thank you too. This has been a great session. It will be available on YouTube for anybody to watch over and over and over. I say we try to immortalize good content by putting it onto YouTube and making it freely accessible. And some of our videos are now and our webinars are now being translated into Chinese and shared on mainland China with the regen farmers there. So you just never know where we go. To the audience, thank you. Some of you have stayed for a very long time. We're nearly 11 minutes over. Thank you so much. And I hope you've all got great value. And we look forward to our next session and we'll keep you posted. So it's bye-bye from me.
Bye, Sue. Thank you very much.
Sue.
Thank you.
Bye.
Thanks, Johan.
Great to be a part of you guys.
Great honor. Thanks.